Time seems to us to be the most obvious reality. We are used to thinking that it flows forward, obeying clocks and calendars, dividing life into minutes, days, and years. But in reality, its nature is far more mysterious. For a child, summer can last forever, every day stretching slowly and brightly. For an adult, years fly by faster and faster, days become similar to one another, and time turns into a swift current from which it is hard to break free. Philosophers and scientists have been trying to understand what time is for thousands of years. Newton saw in it the absolute rhythm of the universe, an invisible motion established from above. Einstein destroyed that picture and showed that the flow of time depends on speed and gravity, and modern researchers, physicists, and neuroscientists go even further, claiming that time may be nothing more than an illusion created by our consciousness. Welcome, my dear friends, to the official channel of Lectures for Sleep, a space where dreams become knowledge and that very voice guides you through the night. Today we will set out on a journey through the mysteries of time. We will look into ancient debates and modern experiments, listen to the thoughts of philosophers and the discoveries of scientists in order to come closer to understanding what lies hidden behind this mysterious flow. Thank you for your warmth and support in the comments. They help to create new lectures and develop this project. If you are not yet subscribed, now is the time to do so. Make yourself comfortable. Close your eyes. Let the day dissolve into silence. We begin our journey into the world of time. Chapter 1. What do we call time? Time seems like one of the simplest and most obvious concepts. We say now, tomorrow, in 5 minutes, and are certain we are understood. We check our watches, make plans by calendars, fill out schedules. Life is divided into weeks, months, and years, and it seems as though everything is under control. But the more carefully we peer into the very concept of time, the more strongly it slips away, like sand running through our fingers. Once, people lived without clocks. Their time was the sun, slowly rising above the horizon and going behind it. Time was measured by the breath of the earth, by the change of day and night, by the coming of spring and winter, by the movement of stars across the sky. It was felt by the body, like the cold of dawn, like the warm breath of a summer evening. With the appearance of the first civilizations, humanity began to tame time. Simple instruments appeared, the gnomon casting its shadow, the clepsydra, a vessel of water quietly counting the moments, the hourglass in which each grain fell with a soft whisper. Later came mechanical clocks with wheels and weights, beating out an even rhythm. And only in the 19th century did humanity establish a unified standard, world time, linked to the meridian passing through the old observatory in Greenwich. Thus was born an invisible grid encompassing the entire globe. Now every country, every city, and every person lives in a system of coordinates where every second has its place. We accept this as the natural order of the world, although in reality it is nothing more than an agreement between people. In the 17th century, Isaac Newton proposed his own understanding of time. For him it was absolute, eternal, and independent. Time is like an invisible metronome, measuring out the beats of the universe. It continues to tick equally in the void and in a noisy room, even if nothing is happening. Time, according to Newton, is a backdrop against which events unfold, but it itself depends on nothing. However, 2 centuries later, this view was shaken. Albert Einstein showed that time does not exist separately from space, but is joined with it into a single fabric. Space-time can stretch and compress, speed up and slow down. For an astronaut in orbit, time moves slightly faster than for a person on Earth. Even clocks raised just 30 centimeters higher count time slightly differently from those left below. These discoveries showed that there is no single time for everyone. Every point in space has its own flow. Time resembles not a rigid metronome, but a polyphonic music. In this music, there are many rhythms that overlap one another, forming a complex harmony. And here a new question arises. If in everyday life we are certain that time moves forward, then what do physicists see? They begin to ask, does time even move at all? Perhaps past, present, and future exist simultaneously, like chapters in a book where all the pages are already written. We merely turn them one after another, feeling the illusion of flow. This thought became the beginning of the most remarkable discoveries about the nature of time, discoveries that still cause philosophers and scientists to argue and seek new answers. Chapter 2. How do we feel time? Physicists seek time in equations, on pages of formulas, and in curved graphs, but part of its mystery is hidden not in the universe, but in ourselves. For what we call time, we perceive not with instruments, but with our own consciousness. And here opens a remarkable world, where the flow of time obeys not the strict laws of physics, but the workings of our brain and our senses, the inner conductor. Our brain is a conductor that tries to bring sounds, images, and movements into harmony. When you snap your fingers, it seems to you that the movement and the sound occur simultaneously, but in reality, the visual signal arrives more slowly than the auditory one. The eye reacts slightly later than the ear. The brain receives these signals at different times, but unites them into a single moment. Thanks to this correction, we live in a world where events coincide and reality seems whole. But this apparent simultaneity is only an artificial construct. To assemble a picture of the world, the brain requires a fraction of a second. It turns out that each of us constantly lives slightly in the past, thousandths of a second behind the present moment. We do not notice this, but it is precisely this delay that allows us to see the world as continuous. When time breaks down, sometimes this system fails. In extreme situations, time seems to slow down. People who have survived car accidents or falls from great heights recall that everything happened slowly, as if the frames of a film had unrolled in slow motion. In reality, the brain at such moments registers far more details than usual. The memories become denser, and it seems to us that the moment lasted longer. There are also reverse cases. Under the influence of drugs, alcohol, or certain medications, people are convinced that hours have passed, when in fact only a few minutes have gone by. Their brain stops registering a sufficient number of events, memory loses its anchors, and as a result, time is compressed. Medical phenomena are also known. One patient with a brain tumor recounted that the world around him was moving at enormous speed. People, cars, even the movement of clouds, everything seemed to be playing in fast-forward mode. At the same time, he himself moved slowly and felt a terrible disconnection from reality. His inner clock had come apart from the clock of the outer world. Scientists believe that such distortions in the perception of time may underlie severe mental illnesses, such as schizophrenia. If a person loses the sense of sequence, causality itself collapses. He may be convinced that an action has already been performed, when it has only yet to happen. Or, conversely, consider that an event occurred without his involvement. Time and biological rhythms. Our personal time depends not only on the state of the psyche, it obeys biological rhythms. Within us, there are biological clocks, groups of neurons in the hypothalamus that regulate sleep and wakefulness. Thanks to them, we feel morning, day, and night, even when there is no sun. But these clocks are not absolute either. In every person, they tick somewhat in their own way. Some people easily wake up at 5 o'clock in the morning. Others come alive only closer to midnight. With age, internal rhythms change. Children feel the days as long, filled with moments, while for adults years fly by faster. Psychologists have calculated that by the age of 60, a person perceives 1 year as almost 2.5 times shorter than a child of 10 years. The reason for this phenomenon lies in the density of memories. For a child, every summer is a discovery, new games, new impressions, new faces. For an adult, the days become similar to one another. Memory stores fewer vivid details. As a result, time is subjectively shortened. Time in culture and perception. Interestingly, different cultures feel time differently. In the Western tradition, it is conceived as an arrow aimed forward. In Eastern philosophies, as a circle or cycle where everything returns. These metaphors also influence how people feel the passage of days. For a peasant living by the seasons, a year is a circle of harvests and droughts. For a city dweller, a linear sequence of calendar dates. In language, we also see this difference. To kill time, to lose time, to save time, as if it were a thing that can be spent and stored. But for other peoples, time is not an object but a stream, one you can enter or exit, our personal clocks. Thus, each of us has our own inner time. It changes depending on the state of the organism, mood, circumstances, and age. In childhood, the days stretch endlessly. In youth, they speed up. In maturity, they speed up even more. We are as if carrying within us unique clocks that tick at their own rhythm, and therefore time in the brain is not a mirror of the physical universe, but a filter through which we perceive it. This filter makes the world consistent, comprehensible, and whole for us. But it also reminds us that the sensation of time is deeply personal, and for each person it flows in its own way. Chapter 3, Time and Memory. If one stops and reflects, our sense of time is connected not only to how the brain processes signals, but also to how it stores memories. For we know the past exclusively through memory, and the future exists only in our imagination. The timeline in consciousness. Memory makes time linear. We remember that an event happened yesterday, that we woke up in the morning and went to sleep in the evening. Without this chain of days, reality would lose its coherence. If we did not preserve memories, every new moment would be like the birth of the world anew. We would live in an eternal now where there is neither yesterday nor tomorrow. But memory preserves the past not like a photograph, but rather like a drawing made by an artist with quick strokes. Some details become brighter, others are erased, others change under the influence of emotions. Memories are unreliable. We are often convinced of things that never happened, and yet it is precisely they that create the sense that time is moving. Memory and imagination. The future is also connected to memory, though in a different way. When we make plans or imagine the coming years, the brain uses the same mechanisms as when remembering. Scientists call this phenomenon chronesthesia, the ability to transport oneself in time. We seem to project our image into a moment that has not yet occurred and mentally live it out. Psychology affirms memory and imagination are two sides of the same coin. We do not simply remember or dream, we build an entire temporal landscape in which the past and future are neighbors. It is this that allows us to experience life as a story rather than as a chaotic collection of moments, emotions, and the density of memories. Emotions strongly influence the flow of time. Happy minutes fly by quickly. We do not record them in detail. They flow like a transparent stream. But anxious and heavy events drag on endlessly. Every second is impressed into memory, like frames of a slow-motion film. Therefore, a day of waiting seems longer than an entire month of everyday routine. In childhood, this effect is especially noticeable. For a child, a year is enormous because it is filled with new events. The first trip, a new toy, a meeting with friends. All of these are separate worlds, and memory stores them densely. With age, novelty decreases. The days become similar to one another, and years fly by faster. We say, time flies. Although in reality, it is not time itself that changes, but the density of our memories, memory and errors of perception. Our brain is constantly editing the past. Sometimes we are certain that a conversation or event happened exactly that way, though the opposite later turns out to be true. Psychologists call this false memories. They can be so convincing that a person is ready to swear to their truthfulness. These distortions show that memory is not a warehouse with neat shelves, but rather a living workshop. Every time we remember, we recreate events anew, and into this process there intrude our emotions, knowledge, and expectations, dreams, and time. Even dreams participate in the creation of the inner chronology. Within a few minutes of sleep, the brain is capable of living through an entire story with many events that seem stretched over hours. In dreams, time flows differently. It can speed up, slow down, or even turn into a non-linear picture. Sometimes in dreams, we live through the future, not in a literal sense, but as preparation. Scientists believe that dreams help us play out possible scenarios. This is yet another piece of evidence. Memory and imagination work together, creating a sense of time even when we sleep. Time as a story. And therefore, one can say, time is not only clocks and the laws of physics, it is also our memory and our dreams and our imagination. We ourselves build the line on which we place the past, present, and future. If memory is a bridge to the past, then imagination is a bridge to the future. Together, they create the illusion of flow, thanks to which we live not in a chaos of moments, but in a story that has a beginning, a middle, and an end. Chapter 4. Time as an Illusion. From the very beginning of human thought, philosophers debated whether time really exists or whether it is only a convenient fiction of our mind. We are used to considering it obvious and inseparable, but many thinkers saw in it a deception of the senses, ancient paradoxes. As far back as the 5th century BC, the ancient Greek philosopher Parmenides claimed, "Movement is impossible, for any distance can be divided into an infinite number of segments, and to traverse it, one must overcome infinity. If movement is impossible, then there is no change. And if there is no change, then there is no time. Everything exists once and for all, motionless and eternal." This thought seems paradoxical, for every day we see how the world changes. The sun rises and sets, trees grow and shed their leaves, people are born and die. But philosophers maintain that this is only an illusion of perception. In the depths of reality, nothing changes. We simply see the same world from different angles. Zeno, a disciple of Parmenides, became famous for his aporious, mysterious puzzles about motion. His celebrated Achilles and the tortoise maintained that the swift hero could never catch up with the slow animal if it had been given a head start. For while Achilles covers the distance to the tortoise, it will have crept a little further forward, and so on indefinitely. The point of these paradoxes was that the very concept of time and motion is contradictory. The modern reflection. Some 2,500 years later, the English physicist Julian Barbour returned to these ancient ideas. He devoted decades to creating a theory in which time does not exist. Barbour describes the universe as a collection of moments, motionless pictures, each of which exists on its own. We feel motion only because our brain connects these pictures into a sequence, like frames in a film. In his conception, the past does not disappear anywhere. It exists just as really as the present, and the future too already is. We simply have not yet reached that page. To say that yesterday is gone is the same as claiming that the number 11 has ceased to exist, because we are now on the number 13. All numbers exist simultaneously, and likewise all moments of time. The equation without time. In the middle of the 20th century, physicists encountered an even more astonishing discovery. In the 1960s, John Wheeler and Bryce DeWitt derived an equation that was meant to unite quantum mechanics and the theory of relativity. But in it, the variable of time unexpectedly disappeared. The universe was described without it. For most scientists, this became a problem. How could this be? The world was changing before their eyes. But for Barbour, it was confirmation. Perhaps at the fundamental level, time does not exist. The universe is not a flow, but a library of motionless pages. The illusion of flow. We, human beings, are accustomed to something different. We live in the sensation of flowing. We remember the past. We await the future. We consider the present to be the movement of the clock hand. But perhaps this is an illusion created by our brain, just as motionless frames of a film, played at a certain speed, create the illusion of motion. If this is true, then our memories are not traces of elapsed time, but separate worlds that exist somewhere in parallel. And the future, too, is already written. We simply have not yet turned the pages to it. Philosophical consequences. This picture destroys the familiar notion of life, but it has its own beauty. If everything exists at once, then nothing disappears entirely. Our days, events, words, and deeds do not dissolve into the past, but continue to exist in this infinite library of reality. In such a view, time is not a flow, but a special illusion created so that we could live through the universe page by page. We do not see the whole book at once, but thanks to this we can experience its chapters one after another, and then it becomes clear. Perhaps the most important thing is not how much time we have, but which page we are reading now. Chapter 5. Disputes about the reality of time. The question of whether time really exists has divided philosophers and scientists into irreconcilable camps. Some consider it the foundation of the universe, without which movement, life, and development are impossible. Others are convinced that time is only an illusion, a product of our consciousness, a convenient construct of thinking that has no real basis. The ancient roots of the dispute. Even in ancient Greece, thinkers asked themselves this question. Parmenides claimed that change is impossible, and therefore time does not exist. His pupil Zeno devised his famous aporias, paradoxes that demonstrated the illogic of motion. In them, Achilles could not catch the tortoise, and an arrow in flight stood still. These arguments sounded strange, but their purpose was clear, to show that the very concept of time is contradictory. Other philosophers, on the contrary, perceived time as a reality. Aristotle defined it as the number of motion with respect to before and after. For him, time did not exist separately, but was the measure of the change of things. In the Christian tradition, the dispute acquired a new dimension. Aurelius Augustine, in his Confessions, wrote that the past exists only in memory, the future in expectation, and the present in perception. What is time? He asked himself. If no one asks me, I know. But when asked, I cannot explain. For Augustine, time was a stretching of the soul, a subjective experience rather than a property of the world. Modern positions. Today the dispute continues, only in the language of science. Philosopher Tim Maudlin states, "To deny the reality of time is to ignore the obvious." He asks, if there is no time, how do we explain aging? Why does everything around us change? For him, the game of denying time is a professional hobby of theorists too deeply immersed in the world of formulas. Maudlin reminds us that the real world is full of changes, and these cannot be dismissed as an illusion. Physicist Lee Smolin goes even further. In his books, he declares, "Time is not only real, it is primary. It existed before the Big Bang and will outlast the end of the universe. Without time, change, evolution, and the emergence of life are impossible." For Smolin, time is the foundation on which the cosmos rests. Experiments and observations. To test the hypothesis of the reality of time, physicists look for signs that the laws of nature have changed. The prime candidate is the speed of light. We know its current value to be about 300,000 kilometers per second. But was it always so? To find the answer, scientists turn to distant light sources. The Fermi telescope observes gamma-ray bursts that travel to us for billions of years. These photons set out when the Earth did not yet exist. If photons of different energies arrive at us out of sync, this means that the speed of light was changing, which means that the laws are subject to time. Such observations continue, and every new flash is like a letter from the past, which may contain clues about whether the laws have changed. If it turns out they are not eternal, then time will become not an illusion, but a proven basis of reality, illusion or flow. But this picture has opponents. Supporters of the block universe concept believe that past, present, and future exist simultaneously. We perceive them as a sequence only because that is how our brain works. At the fundamental level, everything already is. There is no flow. There is only structure, eternal, motionless, complete. This dispute touches not only physics, but also philosophy. If the future already exists, does that mean it is predetermined? If the past is real, can one return to it? Or is all this merely a play of perception, a personal experience, and a universal riddle? We feel time as a flow. We see how children grow, how the world changes, how we ourselves age. Our experience tells us time is real. But mathematics and equations remind us that what we experience may be an illusion. Perhaps we are simply turning the pages of a book that is already written, and therefore the dispute about time seems as though it will never end. It unites philosophy, physics, mathematics, and our personal experience. Some rely on equations, others on feelings. Some see the world as a library of motionless moments, others as a river carrying us forward. And perhaps in this very thing lies the mystery. Time is simultaneously an illusion and a reality, an illusion for our consciousness and a reality for our life. Chapter 6. The Arrow of Time and Entropy. We all feel that time moves in one direction, from the past into the future. We remember yesterday, but cannot remember tomorrow. We grow up and grow old, but we do not become children again. We can break a glass, but we do not see the shards reassemble themselves into a whole glass. This sense of directionality is called the arrow of time, the symmetry of equations and the asymmetry of experience. For a long time, physics could not explain where this one-sidedness comes from. Newton's laws, Einstein's equations, even quantum mechanics, all of them are symmetrical. In the formulas, there is no difference between past and future. If one writes out the trajectory of a billiard ball and then plays it back in reverse, the equations will be equally correct. But in reality, the past and future differ radically. We do not see the reverse flow of events, although mathematics does not forbid it. Why then is going backward impossible in our world? The second law of thermodynamics. The key to the answer was provided by thermodynamics. In the 19th century, the German physicist Rudolf Clausius formulated the second law. In a closed system, entropy, the measure of disorder, always increases over time. Entropy is not simply chaos. It is the number of ways in which particles can be distributed in a system. Ice in a glass is an ordered state, while melted water has far more variance of molecular motion, and therefore melting is accompanied by an increase in entropy. Closely connected with this concept is the work of Ludwig Boltzmann. He explained entropy as probability. Order is possible, but far rarer than chaos. Therefore, the natural course of the world is from order to disorder. The universe as a game of billiards. At the beginning of the world, immediately after the Big Bang, the state of matter was remarkably neat. Energy and particles were distributed almost perfectly. But as time went on, the structure became ever more complex and the disorder ever greater. This is similar to the beginning of a game of billiards. The balls stand in a pyramid and a cue ball strikes and scatters them across the table. First order, then chaos. So too our universe. Once dense and orderly, it is now expanding, increasing entropy, memory, and the direction of time. Entropy explains why time has an arrow. We remember the past precisely because it is associated with lower entropy, with simpler states. The future we do not know because it is open. Ahead lie countless variants. Chaos increases, and it is impossible to predict which outcome will become reality. Without entropy, past and future would be equally real, but devoid of direction. It is the growth of disorder that makes time asymmetrical, the mystery of the beginning. However, an even greater mystery is hidden here. Why did the universe begin with such low entropy? For the natural state of any system is chaos. Why was the starting point of the world so orderly? Roger Penrose, the outstanding British physicist, asserts this is one of the deepest puzzles of cosmology. The initial conditions of the universe were incredibly improbable. The probability of such low entropy at the moment of the Big Bang is so small that it is hard to believe it was accidental. Mirror universes. Some scientists suggest that Perhaps the Big Bang gave birth not to one, but to many universes. In each of them, the arrows of time could have pointed in different directions. In ours, forward, while somewhere in a mirror universe, backward. For the inhabitants of such a universe, their direction of time would be just as natural as ours is to us. They would be born as old people and grow young into childhood. No, rather their physical reality and their perception would be in agreement. They would not see a reversed world, but would consider their own flow natural. At the scale of the multiverse, time may not exist at all. It arises only locally in each particular universe and is always connected with the growth of entropy, time as a consequence of conditions. Thus, a new understanding is born. Time is not an absolute, but a property of our world, arising from initial conditions and the second law of thermodynamics. It is not universal. Perhaps in another universe it would not arise at all. Boltzmann even suggested that we live in a fluctuation of entropy, in a rare region of the universe where order is temporarily high, which allows consciousness to exist, while beyond it, chaos reigns. This idea seems frightening, but it emphasizes that our sense of time is closely connected with the rarity of orderliness, the personal experience of the arrow. However cosmological models may look, for us time remains a personal experience. We feel its arrow in our own lives. We are born, we grow up, we age. We know that the past has already come to pass, the future is hidden, and the present slips away. We understand that a house, once destroyed, will not reassemble itself, that the memories of childhood will never become reality again. All of this is a manifestation of the second law of thermodynamics in our everyday life, the mystery we live through. The arrow of time remains one of the most astonishing enigmas. The laws of physics are indifferent to direction, but our life obeys only one vector. Entropy makes time asymmetrical, but why its starting value turned out to be so special remains a question without an answer. And perhaps in this very mystery lies the meaning. We live through the universe page by page, and each page is irreversible. In this lies the beauty of our experience. Chapter 7. Time and Space. When we speak of time, we most often mean minutes and hours, days and years. This is human time, familiar, measurable, connected with our everyday life. But beyond the earth, another dimension opens up, cosmic time. There, seconds stretch into millennia, centuries disappear like a short breath, and billions of years become a single moment in the life of the universe. The curvature of time. Einstein showed that gravity curves not only space, but also time. The more massive an object, the more strongly it distorts the fabric of space-time. Nowhere is this more vividly manifested than near black holes. Imagine a traveler approaching the event horizon, the boundary of a black hole. For him, everything is going as usual. The heart beats, the breathing is rhythmic, the watch on his wrist counts the seconds. But for an observer from afar, this person seems to slow down. The closer he is to the event horizon, the more slowly he moves, and at a certain moment he seems to freeze, turning into a motionless shadow. For the outside world, his time has stopped. This strange phenomenon is not fantasy, but a direct consequence of Einstein's equations. In strong gravity, the flow of time slows down. This means that in the universe, there is no single rhythm. Every planet, every star, and even every point in space has its own clocks, the age of the universe. If one steps back even further and looks at the cosmos as a whole, we encounter another puzzle. Scientists say that the age of the universe is about 13.8 billion years. But can the concept of age even be applied to the cosmos? For if time arose at the moment of the Big Bang, then before that event it did not exist. There was neither before nor after. The very word age presupposes the linearity of time, and where there was no time yet, such categories lose their meaning. Expansion and the rhythm of the cosmos. The universe continues to expand. Galaxies are moving away from one another, and the further apart they are, the faster this receding occurs. In this cosmic fabric, time is woven into space, like threads in a carpet. The cosmos lives in its own rhythm, and this rhythm does not always coincide with ours. We are accustomed to human scales, decades, centuries, millennia. But for stars, time is measured in millions of years, for galaxies in billions. The life of a star is an entire drama. It is born from a cloud of gas, ignites, burns with light for millions of years, then dies, sometimes gently, turning into a white dwarf, and sometimes with the explosion of a supernova, scattering matter in all directions. This cycle lasts longer than the existence of all human civilizations combined. Light from the past. When astronomers look through telescopes, they never see the present. Light needs time to reach us. The radiation from the nearest star, Proxima Centauri, travels to us for more than 4 years. Light from a star in another galaxy may travel for millions or even billions of years. This means we are looking into the past. Every glance at the night sky is a reading of the cosmic chronicle. We see the stars as they were long ago, long before we ourselves appeared. There is a poetry in this. The cosmos reveals to us ancient pictures, where every moment has already long since passed, but its light is still coming to us. The fate of time in the cosmos. Scientists debate what awaits time in the future. If the universe expands endlessly, the stars will go out, the galaxies will scatter, and the world will end up in heat death, a state where there is nothing left to change. In such a future, the arrow of time may lose its meaning, since entropy will have reached its maximum. But there are other hypotheses. Perhaps the universe will begin to contract and time will seem to reverse. Or, as Roger Penrose believes, after each death of the cosmos, a new one is born, and time flows from cycle to cycle, renewing itself endlessly. The human perspective. We are accustomed to measuring time by our own age, our own history, the life of civilizations. But the cosmos reminds us that our time is merely a tiny stream within a great river. For the universe, the centuries of humanity are an instant, barely noticeable against the backdrop of stellar epochs. And yet this smallness does not make our time less significant. On the contrary, it is precisely because of its limitedness that we feel the value of every moment. When we look at the stars, we understand they will outlive us. Their light will travel for millions of years, even when we are no longer here. The cosmos preserves the memory of the past, and at the same time points to an eternity in which a human life is a brief but shining moment. Chapter 8. Spacetime. When we raise our gaze to the starry sky, it seems boundless and motionless. We are used to thinking that space is a stage on which events unfold, and time a metronome counting their pace. But at the beginning of the 20th century, one man changed this idea forever. Einstein showed that space and time are inseparable. They are bound together into a single fabric, space-time. And it is this fabric that determines the structure of the universe. Simple questions leading to great discoveries. The future creator of the theory of relativity was born in 1879 in the city of Ulm in Germany. Einstein's childhood was entirely ordinary, but from an early age he was distinguished by a remarkable ability to think more deeply about simple things than those around him. In his recollections he wrote that one of the strongest impressions of his life was a small pocket compass device. The needle stubbornly pointed north, and little Albert could not understand what invisible force was governing this movement. Then, for the first time, he felt that the world was not as simple as it seemed. At school, Einstein did not shine, although mathematics and physics came easily to him. Teachers considered him scattered and restless, but it was precisely this restlessness that allowed him to dream. He loved to ask strange questions. For example, what would a person feel if they could race alongside a beam of light? After studying in Switzerland, Einstein worked at a patent office in Bern. The work was routine, checking inventions and drawings. But it was here, far from university chairs, that he began his famous thought experiments. He had no laboratory and no complex instruments, only imagination, paper, and a pencil. Thought experiments. One of these experiments proved to be a turning point. Einstein imagined a train rushing at nearly the speed of light. For passengers inside, a bolt of lightning striking both ends of the train simultaneously seemed like a simultaneous event. But for a person standing on the platform, one strike occurred slightly earlier than the other, since the light from them reached him differently. From this simple reasoning, a grand conclusion followed. Simultaneity is relative. Another image, a lift falling into a shaft. Inside the lift, objects seem weightless, and the person experiences free fall. This is how Einstein understood that gravity and acceleration are one and the same. This principle became the foundation of the general theory of relativity, the fabric of spacetime. Einstein's theory destroyed the old picture of the world. Time turned out to be not a separate flow, but part of a single fabric together with space. Mass and energy curve this fabric, and it is precisely this curvature that we call gravity. Imagine a rubber sheet. If you place a heavy ball on it, the surface will bend, and smaller balls will begin rolling toward the center. In the universe, likewise, stars, planets, and black holes curve space-time, causing everything around them to move along curved trajectories. But not only space is subject to this curving, time also changes its pace. Where gravity is stronger, it slows down. The proof. This is not an ugly metaphor, but the result of numerous experiments. At the National Institute of Standards and Technology in the USA, there are some of the most precise atomic clocks. They measure the rhythm of atomic oscillations with such accuracy that over billions of years they would fall off by only a second. Scientists placed two identical chronometers side by side and then raised one just 30 meters higher, and it turned out that the clock on top ticked slightly faster. The difference may seem minuscule, but it coincided with Einstein's calculations. From this follows an astonishing conclusion. Time depends on place. In the mountains, it flows faster than at sea level. For passengers in an airplane or astronauts in orbit, it moves differently than for those who remain on Earth. There is no single universal now. Each observer has their own, the block universe. Physicists describe this picture as a block universe. Past, present, and future exist simultaneously, like chapters in a book. We live through them in order, like lines, but the book itself is already written in full. From this difficult questions arise. If the future exists, does this mean it is predetermined? If the past has not disappeared, can one return to it? These reflections continue to torment philosophers, Einstein, and fate. For the scientist himself, the theory of relativity was a triumph, but also a severe trial. In 1921, he received the Nobel Prize, though not for relativity, but for his explanation of the photoelectric effect. His ideas were too far ahead of their time. Many colleagues for a long time did not believe that space and time could be flexible. Einstein's life passed in a tumultuous century. He witnessed 2 world wars, left Germany, and settled in the USA, where he worked in Princeton. There he continued to seek a unified theory that would unite all the forces of nature. But until the end of his life, this search remained unfinished. The legacy. Today, Einstein's ideas have been verified by thousands of experiments. GPS navigation, which we use every day, accounts for corrections from both the general and special theories of relativity. Without them, satellites would show incorrect coordinates. His thought games became the foundation of modern cosmology and astrophysics. We feel time as a flow, but Einstein showed that this flow runs within us. The universe, meanwhile, stores all events at once in the fabric of spacetime, where every star, every moment, and every person is already inscribed. And we resemble readers of a great book. We can only see one page after another, but the book itself exists in its entirety. Chapter 9. Multidimensional time. We are used to thinking of time as a line. It stretches forward from the past into the future, and it has only one dimension. But what if this is not so? What if time has hidden dimensions, just as space has more than 3? Space and hidden dimensions. Modern physics has long allowed for the existence of additional spatial dimensions. String theory, one of the boldest and most complex hypotheses of the 20th century, maintains that space is not limited to length, width, and height. It may have 6 or 7 more dimensions folded into microscopic scales. We do not notice them in everyday life because they are hidden within the very fabric of the universe. If space is multidimensional, why should time remain one-dimensional? This question seems audacious, but in the history of science, audacity has often opened the way to discoveries. Once, even the very idea of the Earth revolving around the Sun seemed absurd, a bold hypothesis. The Canadian physicist and philosopher Steve Einstein proposed looking at time in exactly this way. He said, "Imagine that time has not only its familiar direction, but additional ones as well." To explain his idea, Einstein offered a musical metaphor. In music, we hear notes arranged in time. Each note has a beginning and an end. But when they come together, rhythm and harmony are born. This rhythm cannot be described as a simple line. It is multi-layered, polyphonic. It lives in different planes of perception. Perhaps time is structured similarly. Time and the quantum world. If time has several dimensions, this could help explain the strange world of quantum physics. At the subatomic level, particles behave as if the familiar logic is foreign to them. They have no precise position. They exist in the form of probabilities. Sometimes they manifest themselves as particles, sometimes as waves. Perhaps this strangeness is connected with the fact that we see only one cross-section of time, while their true behavior is recorded in other hidden temporal dimensions. For us, this resembles chaos and uncertainty, but in a higher reality, Everything may be orderly, images of hidden dimensions. Einstein compared this to a guitar cable. From a distance it looks like a thin line, a one-dimensional object. But come closer, and we see that it is a cylinder. It has thickness, circumference, internal structure. From a distance, a line. Up close, a multi-dimensional figure. Perhaps time is the same. From our point of view, it is a straight line, but if one looks deeper, it turns out to be a complex figure with invisible facets. Philosophers of the past spoke of something similar. The German thinker Immanuel Kant claimed that time and space are not properties of the outer world, but forms of our perception. We see reality through their prism, but if our prism is limited, then perhaps beyond its edges, time is multidimensional, and we are capable of perceiving only one of its projections. Of course, confirming such a hypothesis is incredibly difficult. The mathematics required to describe a world with several temporal dimensions is complex and often beyond intuition, and proof is for now nearly impossible. We have no instruments capable of detecting the hidden dimensions of time. Even for physicists, this idea remains on the border of imagination, where science meets philosophy and metaphysics. But it is precisely there that new horizons of thought are often born, illusion or polyphony. Perhaps what we call the flow of time is merely the shadow of a more multidimensional reality. Our past, present, and future may be not a line, but part of a gigantic figure where time unfolds like polyphonic music. We hear only one melody, but somewhere nearby, other hidden voices are sounding, which form the general rhythm of the universe. Such a picture of time unites science and poetry. It reminds us that reality may be far more complex and beautiful than we are capable of imagining. The long journey of thought. We have traveled a long way from the ancient philosophers who disputed whether time exists at all, to the modern scientists seeking its traces in equations and experiments. We heard the voice of Newton, confident in the absolute rhythm of the universe, and of Einstein, who showed that time stretches and contracts like a fabric. We looked into the workings of the brain and learned that each person lives in their own time. We heard bold voices from those who consider time an illusion, and from those who see in it the fundamental basis of the world. What is left to us? Perhaps the truth is hidden somewhere in between. For science, time remains a mystery. For us, it is an experience we live through every day. We feel its flow. We see how it changes everything around us. We grow up, we age, we dream of the future and remember the past. And even if in the depths of reality, time is multidimensional or is altogether an illusion, for us, it remains the most real thing there is. Today we close this book, but it does not disappear. It remains in that infinite library of moments of which the philosophers spoke. And soon we will open a new page. You were on the channel about interesting stories for sleep, where dreams become knowledge and the voice guides you through the night. Good night.